Hi, my name is Feabie Mendiaz, and I'm excited to present our research titled Tapping into Bone Marrow Stem Cells for Shoulder Repair, a new regenerative technology. This project was completed with my amazing team members, Bobby Vaish, Nathan Gray, and Brianna von Hedman-Kostek, under the guidance of Dr. Tang in the bioengineering department. We focused on developing a new treatment strategy to repair glenoid labral tears, a common shoulder injury, especially in athletes like baseball players. The glenoid labrum is a fibrocartilaginous ring that deepens the shoulder socket and provides stability. When torn, it has poor natural healing capacity due to its hypovascular and hypocellular nature. Traditional arthroscopic tears involve suturing the torn labrum to the glenoid rim, but these often fail long-term due to the lack of biological integration. We wanted to go beyond just stitching the tear. Our idea was to actually bring the body's own stem cells to the site of injury to promote real tissue regeneration, not just mechanical repair. Our regenerative approach aimed to recruit autologous bone marrow-derived stem cells from the humeral head directly to the torn labral tissue. We came up with a strategy that included two main components: a bone tunnel drilled from the humeral head to the labrum, and a bioadhesive loaded with PDGF, a molecule that recruits stem cells placed at the exit of the tunnel. Since bone marrow is a rich source of stem cells, we hypothesized that by creating a highway to connect torn labrum and bone marrow, we may be able to channel bone marrow stem cells to the tear site for improved labral regeneration. In order to test this, we did an in vivo study using rats. We used 24 rats at two different time points, 3 weeks and 8 weeks, with 4 different testing groups. One group had a standard suture repair, another received only a bone marrow tunnel. The third group received just the PDGF with adhesive, and the last group received both the bone marrow tunnel and the PDGF with the adhesive. Throughout the rat's lifespan, we performed gait analysis each week, and at the final time point, we explanted the tissues for histological analysis. Our histological analysis showed that although we see improvement in solely the PDGF adhesive group, there is still gaps and room for improvement. Through IHC staining, we were able to stain the antibodies CD44 and CD73, which allowed us to view the migration of stem cells. Here we are able to see histological photos of the bone marrow tunnel successfully migrating stem cells to the labral tear. Not only do we see this highway as successful, we also see more stem cells being recruited through this method versus PDGF adhesive alone group. Now we're able to answer the question on if increasing the stem cells does in fact increase the ECM production. To answer this question, we stained for toluidine blue and quantified GAG intensity. We found that there was only a 30.1% difference when compared to healthy tissue. This is by far closest to healthy than any other group. We also used a scoring method called polyscore to determine fibrocartilage health of the labrum, and we saw that the PDGF bone marrow group only had a 20% difference above healthy tissues, while the suture-only group saw a 425% increase. Naturally, we saw that after 8 weeks there was greater improvement in the tissue than 3-week samples, but overall the bone marrow with PDGF adhesive combo showed the greatest results in quality of tissue and fibrocartilage health. By measuring the step length and stride length, we were able to determine that with the PDGF plus bone marrow group, it returned the closest towards a healthy sample, showing that the functionality of the tissue was also great, confirming the quality of the tissue. Through histological analysis and gait analysis, we were able to confirm that the bone marrow channel did in fact significantly increase the recruitment of stem cells and tissue regeneration. In the future, we hope to incorporate anti-inflammatory drugs such as cromolyn to reduce the damage done by inflammation. We will also hope to go into a clinical trial in humans and see how our PDGF adhesive plus bone marrow combination would work in a real human glenoid labrum. Through my research, we were able to find new and faster avenues for regeneration for the glenoid labral tissue, and hopefully will bring comfort back to patients and athletes everywhere. Thank you for watching, and please let me know your thoughts.